All right, let's dive right in. Today, we're going to crack the code of chemistry. I'm talking about the language that elements use to build, well, literally everything around us.
So, have you ever stared at a chemical equation and just thought, what in the world am I even looking at? Like, it feels like you're trying to decode something from another planet, right? If so, trust me, you are not alone. All those little symbols and numbers and arrows, yeah, they can look pretty intimidating.
I mean, just look at this thing on the screen. Seriously, this is just citric acid and baking soda getting together. You know, the stuff you use for a classic science fair volcano. But on paper, it looks like a super complex password for some secret government agency. So yeah, it's totally understandable why this stuff can feel a little overwhelming.
Okay, but what if we're looking at this all wrong? Here's the big idea for today. What if it's not some secret code we have to crack? What if it's just a language we have to learn, you know? A language that has its own alphabet, its own grammar, and its own sentences.
And just like any language, you just need a few keys to get fluent. So, we're going to focus on 4 big ones. First up, the alphabet. Those are the symbols. Then, the grammar. That's something called valency. After that, we'll build words with formulae. And finally, we'll write whole sentences, the equations that tell the chemical story.
All right, let's start at the very beginning. The foundation. We're talking about the alphabet. In the world of chemistry, our letters are the symbols for all the different elements.
So what is a symbol? It's really just a simple, shorthand way of writing the name of an element. And the beautiful thing about this is that it makes chemistry a truly universal language. H means hydrogen, whether you're in New York, Tokyo, or, someday on Mars. Everyone's on the same page.
And the rules for writing them, super simple. Rule 1, the first letter is always a capital. Rule 2, if there's a second letter, it's always lowercase. And you might think, what's the big deal? Well, it's absolutely crucial. Look at the example. Co with a little o is the element cobalt, but CO with a big O, that's carbon monoxide, a completely different and kind of dangerous compound. Oh, and a quick fun fact, some symbols don't seem to match their English names, right? That's because they come from their old Latin names. So sodium is Na for natrium, and gold is Au for aurum. Pretty cool.
Okay, so we've got our letters down. Now for the next piece of the puzzle, the grammar. We need to know the rules for how these letters combine to make sense. In chemistry, that rulebook is called valency.
So what exactly is valency? The official definition is it's the combining capacity of an atom. But what does that mean? It's basically just a number that tells you how many electrons an atom wants to lose, gain, or share so it can get stable and, well, happy. This is like the fundamental rule of how atoms hold hands and make stuff.
And here is my absolute favorite way to think about this. Forget the electrons for a second. Just imagine that valency is the number of hands an atom has to hold on to other atoms. It's that simple. Some atoms have 1 hand free, others have 2, or 3, or 4. This little mental picture, this changes everything. It makes it so much easier to visualize how all these elements are going to link up.
Okay, we have our letters, we have our grammar rules. Now it's time to actually start writing some words. Or, in chemistry speak, we're going to write formulae. And I'm going to show you an amazing, super simple trick to do this. It's called the crisscross method.
And it's literally just 3 steps. 1, write down the symbols. 2, write their valency, the number of hands right above them. And 3, you just crisscross those numbers down to the bottom corner of the other symbol. That's it. Let's actually do one so you can see how easy it is.
All right, let's build a formula for something called aluminum oxide. So, step 1, we write our symbols. We've got aluminum, Al, and oxygen, O. Now for step 2, the valencies. Aluminum has a valency of 3, and oxygen has a valency of 2.
Okay, now for the magic step, the crisscross. And this is the most important part. You only take the numbers. Ignore the little plus or minus signs for now, just the numbers. So we're going to take that 3 from aluminum and bring it down to oxygen. And we take the 2 from oxygen and bring it down to aluminum. See, they swap places. And there you have it. Just like that, the O2 from aluminium now belongs to aluminum, and the 3 from aluminium belongs to oxygen. And we have our first chemical word, Al2O3. That's aluminum oxide. See, it's really that straightforward. Okay, let's keep building on this. If our symbols are the letters and the formula are the words, then what's next? Sentences. And in chemistry, our sentences are the equations. These are the things that actually tell a story. They describe exactly what's happening when chemicals react.
Think of a chemical equation just like a recipe. On the left side, you've got your ingredients. We call those the reactants. And on the right side, you've got the final dish you made. Those are the products. That little arrow in the middle, it just means turns into or yields. But there's one giant, unbreakable rule in this chemical kitchen. You can't create or destroy matter. It's a law. So whatever atoms you put in on the left side, you have to have the exact same number and type of atoms come out on the right.
And that is what we call balancing an equation. And honestly, the best way to picture it is like an old-school balance scale. The total weight of everything on the left side has to perfectly equal the total weight on the right. For every single element, you're basically just doing a head count of all the atoms to make sure nobody went missing during the reaction.
Okay, so let's do a quick recap. Think of this table as your ultimate cheat sheet. Each of these 4 things we talked about has one very specific job. A symbol just names an element. Valency gives you the rules for bonding. A formula tells you what a compound is made of. And an equation tells the whole story of a reaction. If you can keep these separate jobs clear in your head, you'll dodge all the most common mistakes people make.
All right, so knowing all this stuff is great, but how do you make it actually stick in your brain so you don't forget it tomorrow? Let's wrap up with a quick, actionable game plan that's actually based on how our brains are wired to learn.
First, stop just rereading your notes. That's passive. Instead, try teaching it out loud. Seriously, explain valency to your dog or an empty chair. Your brain works harder. Second, use those visual triggers we talked about. When you think valency, picture those hands. When you think formula, picture the crisscross X. It helps. Third, don't study for hours. Do short 20-minute bursts. It's way more effective. And last, right before you go to sleep, ask yourself, what was the one big idea today? Forcing your brain to summarize like that helps lock it into long-term memory.
So there you have it. Chemistry isn't some impossible secret code. It's a language, a powerful universal language that literally describes the fabric of reality. And the coolest part is, you're starting to learn how to speak it. So the only real question left is, what are you going to build with it?